Coming up on How Do They Do It? How does a Mexican beach resort provide world-class hospitality without harming the environment? How do they build cutting-edge flying robots? And how do they produce a medical device that stops a silent killer in its tracks? We head to Mexico to show you how. On How Do They Do It? Globally, tourism generates over $1 trillion per year and is one of the fastest growing industries in the world. But left unchecked, it can cause environmental damage and deplete vital natural resources. But one tourist destination in the southeast of Mexico is doing things differently. So when it comes to turning paradise into a sustainable tourist resort, how do they do it? The Yucatan Peninsula is Mexico's most popular tourist destination. Around 9 million visitors arrive here every year, drawn to its world-class diving, pristine beaches, and outstanding natural beauty. Many visitors head to established resorts like Cancun and Playa del Carmen. But those in the know travel to laid-back Tulum, a coastal paradise that has become a model for sustainable tourism. Leonardo Salas is the Environmental System Manager at Dreams, Tulum's largest hotel.
Lo que buscamos acá lo que es el desarrollo sustentable, ¿verdad? Que todos podamos disfrutar del ambiente, pero sin comprometer a las generaciones futuras.
Hotels and lodgings in the U.S. use over 60 billion kilowatt hours of electricity every year. That's enough to power the whole of Switzerland for an entire year. So how does Mexico power its tourist industry in a more sustainable way? With Tulum's sunny climate, there's an obvious answer.
So if we're down here...
Solar energy expert Tamara Lashbrook helps businesses install their own electricity system.
We can't really move over that way anymore. We're not going to have room for the panel.
First, Tamara finds the best spot by using a sun chart. This device shows which parts of the roof will be in shade at different times of the day throughout the year.
What we want is a clear window between 9 a.m. and 3 p.m., and it doesn't get much better than this.
Tamara positions panels on a 20-degree angle to soak up the most rays. The electrical current they generate flows down into a battery bank inside the building.
You're really creating your own mini power station.
But to reduce its energy consumption, Tulum has other innovative solutions. Architect Carlos Alamillo is an expert on eco-building techniques. Relying on naturally cooling stone, his designs channel the breeze and reduce the need for air conditioning.
You're going to have a flow of air always going not only east-west, but also up and down the house. The wind circulation is kind of in an 8 motion.
While vacationing, tourists use up to 440 gallons of water every day. That's enough to fill around 18 bathtubs. But with no rivers on the peninsula, how can Tulum meet this demand? The answer is a geological wonder just below the surface. A giant web of streams, rivers, and caves stretches for thousands of miles beneath the Yucatan. So when looking for a water supply, all hotels need to do is drill into the ground. With its abundance of natural resources, Tulum has a built-in advantage over other tourist destinations. But with very little soil, one aspect of sustainability requires an ingenious solution. Still to come, How does a Tulum farmer grow Far Eastern ingredients on a bed of pure limestone?
So you want to go look at the garlic now?
How does a factory in Baja California build the latest robotic device? Join us after the break to find out more on How Do They Do It? Tulum, Mexico is leading the way in ecotourism. Green Beet Farm, set up by a DJ turned eco-farmer, Javier Fuchs, grows produce for local restaurants. But with almost no topsoil in the area, he first has to create raised beds and fill them with his own homemade compost.
You pick it and you smell it. Smells like really humid, smells really nicely, and that's when you know you have good soil.
To cut down on Tulum's carbon footprint, Javier grows some unusual ingredients. Dim Gifei is a consultant chef at Mezzanine, a Thai restaurant in Tulum. She used to import fruit and vegetables from her native Thailand. Now, she just heads down the road with a basket.
So you want to go look at the garlic now?
Thank you.
So we have like Thai garlic, we have Thai basil, we have amazing lemongrass, we have Thai chives.
Back at Mezzanine, Dim cooks up her bounty into traditional Thai dishes. With satisfied customers, it looks like Javier's produce and Dim's culinary skills are a winning combination. Hotels and restaurants generate a lot of waste. Luckily, a local company called Maya Verde has a clever solution for recycling some of the waste. Sandra Martinez is its director.
What we do is we collect all the used oil from the kitchens from hotels and restaurants.
Sandra and her team pump the oil into plastic containers and take it to Maya Verde's factory.
We use the cooked oil, and then with a chemical process, we transform it into a biofuel.
Hotels in the area then use that biofuel to heat up their water.
This helps to reduce up to 70% the emissions from the boiler. And with all the oil we collect, we save that oil from going into the water and contaminating the ocean.
By establishing sustainable solutions now, the people of Tulum, Mexico, hope that visitors can enjoy their amazing hospitality, world-class restaurants, and outstanding natural beauty for generations to come. Unmanned aerial vehicles give anyone from athletes to farmers an eye in the sky. These gadgets intelligently fly on their own. They can be programmed to follow a map, fly above water, and like a homing pigeon, return to where they took off. All at the swipe of a screen. So when it comes to building the latest in robotic technology, how do they do it? Baja California, Mexico has long been a center for electronics manufacturing. And now it's home to ambitious startups like 3D Robotics. Co-founded by young entrepreneur and inventor Jordi Munoz, the company taps into the growing market for personal unmanned aerial vehicles, or drones as they are more commonly known.
The first design didn't work, but then I jumped to airplanes. It was in 2008 when I was able to make my first airplane to fly completely autonomously, and probably was one of my best days of my life.
Since then, the company has grown to 180 employees, with offices in San Diego, Berkeley, Austin, and Baja California. Their best-selling device is the Iris. This flying beetle is made up of sophisticated hardware housed in a central core, lightweight nylon arms, and 4 rotors. Most commonly used to film aerials, the Iris comes with a mount for a small video camera. But drones are more than just toys for grown-ups. Wine growers use the Iris to monitor their vineyards. And archaeologists map inaccessible areas by filming from above. But to do all that, the drone needs a solid structure. Four rotor blades lift the device off the ground. Technician Sandra Lucero inserts the blade's motors.
Llegan los motores así y los pongo lo que son en los brazos y sí, pues algo muy importante porque sin el motor pues la pieza pues no puede volar.
Once soldered to a power board, the motor and arms move to the main assembly line. The drone is starting to take shape, but it's still missing its most important component. Still to come, how do they build a flying robot's brain? Join us after the break to find out how on How Do They Do It? In Baja California, Mexico, 3D Robotics is hard at work building the Iris, their most popular personal drone. The drone contains an autopilot device known as the Pixhawk. To create this sophisticated hardware, Cesar Macias first lays a stencil over a pre-printed board.
Tengo que asegurarme que mis pads coincidan con el stencil para un mejor empastado.
He then covers the stencil with a paste made of aluminum and lead. The machine smears the paste, filling the gaps in the stencil. The board then passes to the pick-and-place machine. As the name suggests, each of its reels is programmed to place components onto the board. The components attach to the applied paste, but at this point, it's a little like bread dough. To cement the electrical connections, an oven bakes the circuit boards at 482 degrees Fahrenheit. Once detached, the boards are added to a plastic casing. The Pixhawk then attaches to a navigation device with a GPS and electronic compass. To protect its high-tech hardware, the Iris needs a tough outer shell. In order to fly high, the device also needs to be lightweight. That's why it's made of ABS plastic, the same material used in the construction of car bumpers. To create the shell, 3D Robotics turns to a local plastics factory owned by Carlos de la Torre. The shells start their life as these tiny little pellets. To color the plastic, the bucket contains pieces of black pigment. To turn the plastic into a workable consistency, it first needs to be melted.
The plastic goes into the machine. It'll get heat up to 485 degrees and it'll turn into a consistency of toothpaste.
That molten plastic is then injected into the mold at a pressure of 10,000 pounds per square inch. Once the parts are set, Carlos and his team then box them up. Back at 3D Robotics, workers attach the plastic shell to the Iris's body. But before the drone can leave the factory, it needs to be tested. Standing safely on the other side of the glass, Chief Pilot Daniel Hernandez first tests how the drone takes off. He then checks its steering. Finally, he lands the device.
Desde chico siempre me ha gustado el radiocontrol, todo lo que es radiocontrol, y hasta ahorita tengo este trabajo que me gusta mucho.
These devices aren't designed for indoor use. So to really test them, they need to get out in the open air. On the beach, Jordi programs in a route using his tablet.
As soon as I fill up the mission, I can just click transfer. It's gonna say all the information to the drone, and it's gonna execute the mission I just programmed. Basically, the drones know what to do, how to take off, where to go, and then where to land.
As the drone soars high in the sky, it appears to be working perfectly. Jordi and his team here in Mexico can now get back to developing and building the next generation of drones. Still to come, how do they create a life-saving medical device from nothing more than wire and fabric? Join us after the break to find out more on how do they do it. Abdominal aortic aneurysms are one of the leading causes of sudden death in men over 60. In the United States alone, this condition affects 1.2 million people. Now, an innovative device is revolutionizing how patients are treated. In the past, the only option was risky and invasive surgery. Now they can be in and out of the hospital in 24 hours. So, how do they do it? Today, Mexico is one of the world's leading manufacturers of medical equipment. And one of the biggest companies is Medtronic. Here at their 350,000 square foot facility in Baja California, they produce cutting-edge medical devices, including the Endurance Stent Graft. This deceptively simple device is fighting the war against a silent killer, abdominal aortic aneurysms. Left untreated, these bulges within the artery can rupture. And when that happens, it's usually fatal. Surgeons treat the condition by inserting a tube that bridges the damaged area, called a graft. Before, that was only possible through opening up the abdomen. Now, surgeons can insert an endovascular stent graft through an incision in the upper leg, and then guide it along the artery until it reaches the correct position. Gerardo de la Concha is head of operations at the Mexico facility.
This product line is very, very close to my heart because in 1979, my father had a aneurysm himself, and he went through a very, very difficult surgery.
Surgery always carries some risk, but this newer procedure doubles a patient's chance of survival.
Probably the next day you will be walking out of the hospital, so it is amazing therapy.
The trouble is, when you're making something that will stay inside a human body, the tiniest contamination could be life-threatening. So before working, employees must go through a rigorous cleaning process. They don surgical gowns, hairnets, hoods, boots, and gloves. Once inside, the team bags up the 20 different components which make up the Endurance Stent Graft. That pack is then brought to the sewing section. Here, the sewers begin by attaching rings to a fabric tube. Made of a unique nickel titanium alloy called nitinol, these rings give the tube its structure. They also have an elastic memory, meaning that when they are squeezed and released, they bounce back to their original shape. Manufacturing supervisor Christian Sanchez oversees the complex process.
It takes around 14 hours to get a whole unit complete.
To be on the safe side, the sewers use a special stitch to attach the rings. This stops everything from unraveling if one part catches or breaks. Once all 19 rings have been sewn into place, the stent graft passes to Nancy Martinez, who adds in the final critical part of the device.
Pues yo hago la última parte, que es finish, que es pegar el supra.
This supra, or suprarenal stent, anchors the device in place by hooking onto the walls of the artery. But the stent graft is far too big to insert directly into the body. So first, it needs to be compressed into an ingenious delivery system. Christian Sanchez demonstrates how this works using a glass model. Like putting a ship in a bottle, this 3-foot-long tube carries the stent graft along the artery. Once in position, the surgeon opens it up. To get the devices out of the clean room, they use this high-powered vacuum. Blasting off like a space rocket, they emerge seconds later in the shipping department. Once packaged up, they are sent out from Baja California, Mexico, to eventually save lives in hospitals all over the world.